Alrighty, so for today's lesson, what we're going to do is talk about conditionals and related statements. And a conditional statement is a logical statement that has two parts. It's got a hypothesis and it's got a conclusion. When it is written in if-then form, the if part contains the hypothesis and the then part contains the conclusion. So something like this, if-then. If it is raining, then there are clouds in the sky. So basically you're taking two simple sentences, it is raining, and then there are clouds in the sky as the second, and then you're connecting them with an if statement, then statement. So then the next thing that you have is we're talking about conditionals being if P then Q. Symbolically is you're going to have an arrow. So what it looks like is if P then Q. That's how you would write it symbolically. So here's the scenario. Your mom tells you that if it rains in the morning, then I would drive you to school. But it's only if it rains do I need to drive you, or does she need to drive you. So when you fill out your truth tables for your P's and Q's, the first one says, well, was it raining in the morning? And the answer is yes, it rained. Did you get your ride to school? Yes. So therefore you're not told a lie, your mom told you the truth. Next day, does it rain in the morning? Yes. Did you get your ride to school? No. Well, your mom lied to you. These next two examples, it never rained. Remember, the scenario says if it rains in the morning. Well, if it doesn't rain in the morning, your mother can do whatever she chooses, and she's never going to lie to you. So whether it rains, if it doesn't rain in the morning and she drives you, or if it doesn't rain in the morning and she doesn't drive you, she's never lied to you. So the only time that a conditional statement is false is when the hypothesis is true and the conclusion is false. Okay, we've got a whole bunch of related conditionals that we need to deal with. The first related conditional is the converse. The converse basically says you need to change the order of your conditional. So for my conditional, and when I look for the converse, it would be actually if Q, then P. So when I fill out my chart, right here, this right here talks about the rain in the morning. This right here talks about the ride. Well, it rained, you got your ride, all is well. It didn't rain, you got a ride. It doesn't matter, it never rained. It rained, no ride, not good. It didn't rain, it doesn't matter what happens, it's true. The inverse. The inverse says, well, with the conditional, I am going to negate it. So conditional means I negate, which means once I always start off with my conditional, if I negate it, then it becomes not P. If not P, then not Q. I just negated each piece. So fill in your truth table in the beginning. And then not P's are F, F, T, T, F, T, F, T. So now what happens is the inverse is going to be not P is my hypothesis and not Q is going to be my conclusion. So it didn't rain, doesn't matter, never lied to. Didn't rain, doesn't matter, conclusion, never lied to. It rained, no ride. Here's where I was lied to. It rained, I got my ride, I was not lied to. Contrapositive. Change order and negate. Change order and negate. So when I look at the original conditional, I'm going to change my order and I'm going to negate it. If not Q, then not P. Again, fill out your truth table for the beginning. Alrighty. So this time, your hypothesis is not Q, that's your rain. And then this becomes your ride. So as I look here, it didn't rain in the morning, doesn't matter what happens, wasn't lied to. It does rain, I didn't get my ride. Didn't rain, doesn't matter. Does rain, got my ride, all is good. So the conditional statement and its contrapositive. If you go back and look at both of those final columns, they have the same exact final truth values. And if you ever have the same final truth values, you're considered to be logically equivalent. So the conditional and its contrapositive will always have the same final truth values. Okay. So write the converse, inverse, and contrapositive of the following. Determine the truth value for each. Well, if they tell you that the measure of angle is 99 degrees, then the measure of angle is obtuse. And that is true. If you do the converse says, change the order. If the measure of angle A, if angle A is obtuse, actually, I don't need the measure. If angle A is obtuse, then angle A equals 99 degrees. Well, that's false because an obtuse angle can be any angle that's greater than 90. Inverse, I go back to my conditional and I negate the original. If angle A does not equal 99 degrees, then angle A is not obtuse. Well, just because it's not 99 degrees doesn't mean it can't be obtuse. It could be 100 degrees and it will be obtuse. So this happens to be false. Contrapositive, change order and negate. If, in this case, if angle A is not obtuse, then angle A is not 99 degrees. Well, even before I reason this out, if the converse and the contrapositive are logically equivalent, then the fact that the, sorry, I didn't say that right. If the conditional and the contrapositive are logically equivalent, then the contrapositive must have a true truth value. Reason being is if the angle is not obtuse, there's no way it can have a 99-degree measure. Okay. If a polygon has 5 sides, then it is a regular polygon. You need to remember that regular in this case means congruent sides and congruent angles. It's an angle symbol. So if we do the converse of that, it's going to look like if a polygon, I think it's a pentagon is what I'm missing from that's covered up, but if a polygon is a regular pentagon, then it has five sides. Well, let's go back up to the beginning, which I didn't talk about the truth value for the conditional. If a polygon has 5 sides, then it is a regular pentagon. And that's not true. So this thing right here is false because it doesn't have to be a regular polygon. 5 sides, it could be any pentagon I want. I don't have to have equal sides and equal angles. When I do the truth value for the converse, that the polygon is a regular pentagon, then it has 5 sides. So that would be true. So if it's a pentagon, of course it has to have 5 sides. If I take a look at the inverse, when I negate, this is going to be if a polygon does not have 5 sides, then it is not a regular pentagon. And that has to be true because if it doesn't have 5 sides, you can't be called a pentagon. And then we get to our contrapositive. The contrapositive says if the polygon is not a regular pentagon, then it does not have 5 sides. And if it's not a regular pentagon, then it does not have 5 sides. Well, it doesn't have to necessarily have the 5 sides. If I'm not a regular pentagon, then I can have as many sides as I want. It doesn't really make a difference. Bottom line is it is the logically equivalent to the conditional. Okay, we've got this last couple things here. Write the statement that's logically equivalent. If a polygon is equilateral, then the polygon is regular. So if we want to be logically equivalent, we're looking to do the contrapositive, which we would write then if a polygon is not regular, then it is not equilateral. Write the logically equivalent for this one. If you prepare for the test, then you cannot fail. This would be if you fail the test, then you did not prepare for the test. And then what is the inverse of if two lines do not intersect, then they are parallel? Inverse means I negate. So you would say if two lines intersect, then they are not parallel. Okay? So that should be good for you to go ahead and finish your homework. So it's inverse, converse, contrapositive. Everything bases off the conditional. Converse is change order. Inverse is I negate. Contrapositive is change order and negate. And the conditional and the contrapositive are always logically equivalent. Good luck on your homework.